segue to Bruce's talk because he has these amazing data sets. So let me just jump right into Bruce's presentation. So it is my great pleasure to introduce Bruce Weinberg. He received his PhD in economics from the University of Chicago before joining the faculty at the Ohio State University, where he's now a professor of economics and public affairs. One of his many areas of research is in economics of innovation and creativity. This work studies the production, diffusion, and value of innovations, including how creativity varies over the life cycle, how an individual's own creativity is affected by the presence of other important innovators, and disparities among researchers. He has helped create, as I was saying, extremely detailed data sets around science and innovation. And today he will be presenting Umetrics, new data and findings. So help me in welcoming Bruce. Bruce.
Daniel, thanks so much. And Stephen also, and Sasha, you're obviously a tough act to follow. I'm going to do my best here, but I'm really excited to be here. And, in thinking about the science of science, in some sense, maybe I shouldn't be here because I'm going to try to argue a little bit that maybe the interesting thing is the science of scientists as much as it is the science of science itself. And I think that's something that came through a lot in your talk also, that, we need to be thinking about the careers of the people who are actually conducting the research. But so, so I'm going to be presenting some stuff that uses data that we have connected to the Census Bureau, and our views don't express the views of the the U.S. Census Bureau, obviously. But the premise of what we're doing is that people and the ideas that they produce are more important than the classic research products that a lot of people have been focusing on. And so, what we've been trying to do is to develop ways of identifying people and the roles they play in the production of science and the ideas that they're producing, and treating documents and citations and things like that as measures of the research that's being produced, but not as the object of interest in itself. And this isn't, as you'll see, this is not, well, I don't think it's trivial. Maybe you guys do, but this is you can see the light pole and the proverbial person searching for their keys underneath the light. It's no mystery why people have focused so much on research artifacts, research products. It's easier to identify them, right? Tracking people involves complex computer science problems, far beyond my personal abilities, and data that are not easy to get a hold of. But that's really been the effort that we've been engaged in, is trying to figure out how we can see the role of people in the production, diffusion, and producing and realizing the value of ideas. And as Sasha said, and I'm an economist, the way I got into this is I'm interested in what's gonna make the society better, especially economically. I'm going to talk about two different initiatives. The primary one is the Institute for Research on Innovation and Science, IRIS, that's run by Jason Owen Smith at the University of Michigan. Also, Julia Lane at NYU has been deeply involved, Ron Jarman at the Census Bureau, and many other organizations. We now have 72 campuses across the United States that are providing data, and I'll describe a little bit more about that data. The second is a program project called Innovation in an Aging Society. It's a program project that's funded by the National Institute on Aging, trying to understand the production and diffusion and value of research, especially as it relates to the aging of innovators and the aging society. That as as our society ages, our needs for innovations and especially biomedical innovations are going to increase. And one of the things that we've been focusing increasingly here is on Alzheimer's disease, where, you know, obviously there's a tremendous need for innovations. But both of these projects are geared around identifying the role of people in the production, diffusion, and realizing the value of research, and also in producing data that will be available to the research community, is available to the research community. So let me talk to you a little bit about our data architecture. It's a little bit wonky perhaps, but I think it's important, and hopefully it'll serve as an advertisement for folks who might have some interest. So what we've done, Umetrics data are the back end of payments on sponsored research projects at, I say, 72 universities across the United States. We're not complaining that this is nationally representative data. They're skewed towards research intensive institutions, but but it's a large number of institutions, and they're covering about 40% of academic R&D in the US. So it's pretty wide coverage. They're the back end, as I say, of payments on sponsored research projects, and that may sound a little bit wonky, but what's cool about them is from the payments on research projects, you can identify every person who is employed on a research project and which project they were employed on. And you can also identify what role they played. We have job titles on them. We know how much time they charged to the project. And we can also identify all the purchases of inputs that occurred on those projects. So that's these Umetrics data. They've been attached to public information on awards. So we can see award abstracts and titles and so forth. We've also been matching these to publication data, both from PubMed and from the Web of Science. So we can identify the research projects that came out of these projects and were produced by the people. And Sasha was talking about this sort of the growth of teams and who's on papers and what roles they play on papers. You know, we have the ability to see, you know, who's a staff person, who's a graduate student, who's faculty, who's a postdoc. We have the ability to see how much time they got paid and whether they appear on a publication, how that varies with the size of the team or the nature of work that they're doing. We've spent a lot of time disambiguating, especially PubMed. That's work that's been done by Vetle Torvik and Neil Smallheiser. Their data is freely available. I'll show you in a second. It's really very high, high precision, high recall data for an algorithmic attempt to effectively boil the whole ocean. We've matched people to articles to citations. We generate natural language processing novelty measures. We match researchers to their dissertations so we can see what they studied, where they studied, who they studied under. We're imputing things like gender, race, ethnicity, affiliations. We're starting to try to link folks to transcript in the survey of earned doctorate, so we have more background on people. We're matching people to their patents that they receive. And then one of the cool things that we've done is we've taken these Umetrics data and then we've matched them to the Census Bureau, to data at the Census Bureau. And the Census Bureau, in addition to the decennial census that we all fill in to determine how many votes we do, or maybe in this case don't get, they have a wealth of data from across the federal government. So they get tax returns from the IRS. They have unemployment insurance records that they receive from states. Their data on startups. So there's just a tremendous amount of data. These data are obviously very sensitive. You need to go through a background check, use them in secure facilities, lock up your cell phone. These are not, I hope it goes without saying that the Census Bureau isn't, just posting your tax returns online. But they are accessible, and they're accessible to researchers for approved projects. We are doing imputations. These data are freely available. I can help connect you with them. They're Vetle Torvik stuff. Umetrics data itself is being provided by member institutions to the University of Michigan and Node. the University of Michigan operates a secure enclave, a virtual digital enclave that you can use remotely. And so if anyone has any interest in that, reach out to me, Google Umetrics, and contact the University of Michigan. And then, as I say, you can also access data that have been linked to census data through the Census Bureau. And this is they handle that process. We're completely disconnected from it. They have an approval process, but those data are accessible. And I encourage folks to whatever, if you have an interest in any of them, reach out to me and I can help you figure out, so do you use our public data? Do you use the data in the enclave that we've provided? Or do you want to kind of go through the Census Bureau and get all that stuff? What are your interests? But our goal, our goal is to get these data used. So one thing that we've done, and I'll just show you some results from these data. That's basically what I'm going to spend my time talking about. Is to look at who's employed on research projects. And I think there's been the sense that research projects, sort of, maybe if you talk to folks in Congress, is research funding goes to support faculty welfare queens and lab coats. And maybe there's an element of that, but that's the overwhelming minority of who's supported on research projects. If you look at who's supported on research projects at NSF, in the top, it's disproportionately graduate students and some postdocs, but it's trainees. If you look at NIH, they're much more staff. But in all cases, trainees are a larger share of people employed on research projects than faculty are. And staff are very important at NIH. Not surprisingly. We've tried to see what's happened to folks after they've given the importance of trainees. We try to understand, can we get some sense of the value of this training by looking at where people are going after they graduate. And so we've done this. We've taken our Umetrics data, we've matched it to ProQuest. We identify the fields that people study in, and then we use the W-2 data and the unemployment insurance data at the Census Bureau to match people after they graduate to the firms that they work for. And increasingly, we're tracking them longitudinally over time. We can basically get you if you're in a covered position in the US. If you leave the US, obviously, we lose track of you. But I think the results here are pretty striking. That if you look at people who are leaving after they graduate, a large portion of them are going into academia. That's probably not surprising, but a large portion of them are going into industry. And of the people who are going into industry, a huge share of them are going into R&D performing firms. More people are going into R&D performing firms. Far more people are going into R&D performing firms than the workforce as a whole. And far fewer are going into non-R&D performing firms than the workforce as a whole. We've looked at this is an older paper. We can do this more recently. The results hold up, but we have the spiffy figure here. So we had 8 institutions at the time that we did this, and for 6 of the 8 institutions, more people stayed in the state in which they trained than went to any other single state, which we thought was striking. Because if you look at these, and I'm a Buckeye, OH. I think I heard someone say IO there, which is awesome. But, let's face it, these aren't the states that you probably thought of as the place where, bright, young, highly trained technology STEM workers were going to be going. But you know what? 3/4 of the institutions, more people stay in those states. And we think that's very powerful. I mean, especially being at a state institution, that's the kind of information that state legislatures want to understand. I think they understand why we're training undergraduates at Ohio State. I think sometimes it's important to remind them that this is actually an engine of growth for the state, for our state. Obviously, lots of people go to California. That's because California is the #2 destination or #3 destination or what have you for lots and lots of different schools, even though for most schools, the home state is the primary destination. We've also broken things down by field. As I said, we match to ProQuest. We know what these folks studied, and we can look at their earnings. They seem relatively naturally ordered. We can look at whether they get jobs in industry, whether they get jobs in an R&D performing firm, whether they get jobs in a high wage firm, whether they get jobs in a startup. And in general, folks are going to high wage, high tech R&D performing young firms, right? This is a group of people who are going to the types of jobs that we want them to be going to. We've looked at gender disparities, and we've used our census linked data to look at gender and marital status and family structure using the 2010 decennial census. We'd love to update these data as soon as the 2020 decennial census comes out. It'll be very interesting to do, and then to W2 and LEHD earnings data. And so if you look at things, I saw some people with tears in their eyes in Zoom. There probably some time for some tears here. If you look at women, women earn about 1/3 less than men do, and you can see sort of the curve for men is sort of bimodal. There's sort of a hump sort of at a postdoc salary, which is where sort of the women, for the most part, have the peak probability of being. But there's a second hump that's sort of more like at a faculty salary. And for women, there's sort of a little bit, things aren't falling, the density isn't falling as much at that point, but there's no second mode, and it's much lower than for the men. Two things turn out to explain this entire gap. So there's a 1/3 gap between men and women. 2/3 of the 1/3 is explained by field of study. So women study, biology and health, and men study computer science and engineering. This is obviously a gross overgeneralization, right? So, but that's the overwhelming. That's a strong pattern in the data, and it explains 2/3 of the gap. The second is that women experience a pretty substantial penalty for being married and having children in terms of earnings. And that explains the other 1/3 of 1/3. So those two factors completely explain the gaps between men and women. We've tried to use our data to look at what, I think one of the pitfalls that people have had is they focused sort of on publications and citations and patents. And I'm probably guilty of that just as much as anyone else is. And then the other thing that people, and especially if you're an economist like me, it's a natural pitfall, is to focus on money. And everyone's interested in money and what happens to money and what should be done with money. But what we wanted to try to do is to use the data that we have to say how does money actually translate into producing science, right? We kind of know, I think, that dollar bills don't produce science, that people produce science, and that money is used to hire people to work on those projects, and it's used to purchase things that they need in order to produce that research, and try to understand sort of how that whole process works. So this is what, if you're an economist, it's sort of this Zvi-Grilich's problem. How is it that resources translate into the production of research? What are the time lags? Are we better off having a few large labs or a large number of mid-size or small labs? Sort of how productive are labs at different size? How should we measure productivity? These sorts of questions that we're where we wanted to get an answer get at as economists. The concern, the obvious concern, and I know that some of the lectures that you had were regarding causality, and I'm an economist, so economists basically, as an empirical economist, basically all empirical economists do is focus on causality issues. Here the causality concerns are pretty self-apparent, right? Ideally we would love to randomly distribute resources to different researchers and see what happens to their productivity. Obviously, as anyone who's applied for a grant knows, they go through rigorous review processes. Money is not randomly assigned to people, right? It's very self-consciously awarded to the people who, at least the reviewers believe, in their cases, where it seems like that got wrong, right? I mean, there's these, amazing story of Katalin Kariko and, not getting funded for all of her research on mRNA and so forth. But, in general, we think that we're assigning resources to the people who are most productive, which would tend to mean that we're getting a biased picture of the value of resources, because the people who have most resources, not only do they have more resources, but they probably have the most promising ideas to work on. And so we kind of need a way of addressing that. The other concern, which we think is real, and is true, we think, in biomedicine, is that you're going to assign more research for a given social value of a project. You're going to assign more resources to the more costly projects. And so, the example that we have is clinical trials. Clinical trials tend to be very, very costly. Obviously, they can be socially extremely important. We need to know whether these things that we're developing are valuable or not. They don't necessarily yield huge numbers of publications given the amount of resources that they involve. So the other thing is, on the one hand, we're assigning money to people who have the more promising ideas. On the other hand, we're assigning more money probably to things that are more costly to do. And this would tend to actually bias us towards a lower estimated value of research. So how are we going to try to address this causality concern here? One thing we're going to do is we're going to be including researcher fixed effects. So we're going to look at a particular researcher over their career and when they had more money and when they had less money, and see if they're more productive in the years that they had more money than in the years that they had less money. The second thing is to use something of how funding is allocated, and this is sort of our picture of how funding is allocated to the National Institutes of Health. This sort of at the bottom center is Francis Collins, and he is having a nice friendly chit chat with his buddies on Capitol Hill and trying to tell them what where they should put their money. Obviously, we believe that Congress allocates money to the things that they think are most important for improving health, but there's also a political process. And so what we're going to do is we're going to attach researchers to the NIH Institute or Center that has funded most of their research in the first year we see them in our data. So basically, the National Institutes of Health are divided into, I believe it's 27 institutes and centers. Most people really get most of their money from a single institute or center. Here we're showing that 80% over the course of your career of the funding that you receive is going to come from the institute or center that provided the most funding for you in your first year of your career. So we're going to say, let's look at shocks due to this, charming congressional process to funding for specific institutes or centers, and then say, we now are going to attach researchers to those institutes and centers and say, if this institute or center got a shock to funding, how much of that would have likely increased the access to resources for that particular researcher. We're also doing fixed effects, as I say, and we have another strategy that we're working on now. So this is what we get. We're estimating here research funding. This is total funding, including direct and indirect costs in millions of dollars per year. to the number of publications that people produce in the 3 years after they receive that funding. And what you can see is that there's a pretty strong steep, relationship. These are ordinary least squares. These are if we look at changes in funding across a researcher's career, and that at some point it starts to flatten out. And these are polynomials, so we're imposing a functional form. I'm not sure how seriously we take the downturn part, but at a very least it starts to flatten out. But then the other thing that you can do, and I'll say that a lot of people have made a lot of this. A lot of people in the National Institutes of Health have implemented policies that sort of Robin Hood policies that basically involve taking resources from people who have large labs and large amounts of resources and trying to redistribute them to smaller labs and people who have less resources. And just to be clear, I'm not arguing against that. I think there are lots of reasons that makes sense, but I'm not sure that this is the argument to do that. And if you want to see why, this up here is the distribution of resources. So it's true, there are some folks out here who are getting 5 and 10, who run labs that have $5 and $10 million a year in funding. But man, and I have crummy eyesight at this point. It happens as you get old. But man, those bars out there are not very high compared to all these bars down here. The overwhelming majority of folks at NIH is funding are on the very, very linear portion of this curve. So I think if you said, oh, I want to take some money from these guys out here with 5 and 10 and 15 or whatever $1 million a year and give it to some of these folks down here with a few $100,000, God bless. But I'm not sure that you want to say, oh, I'm going to go take a lot of money from these people with $1 million and give it to the folks with $100,000, that's going to produce a lot more science. There may well be a good justification for that in terms of generating a more inclusive, more broad-based workforce, helping people establish independent careers. I support this policy from those perspectives, but in terms of producing more science, it's not clear that that's going to do much for us. We've got a whole bunch of fancy specifications and we can go through them. I don't know how much we want to spend on that. One thing that we've done though is we've broken things down by the quality of work. So one thing you might say is you say, look, we're giving this money to these people, they $1 million, $2 million, what have you. The productivity isn't so bad, but maybe the quality of that work is really crummy. Maybe they're just sort of turning the crank and they're putting out low quality work. That turns out not really to be the case. So if we have a whole stack of measures, we have citation counts, we have measures of the diversity of citations, we have the rank of journals. I know people hate citations and they hate impact factors even more than they hate citations, but these do have some value. We have use of new text concepts. So are you using sort of the most cutting edge ideas? So, and I'm not sitting here arguing that any of these measures are right. In fact, they're probably none of them are right, but they give us a picture and they provide a sort of consistent picture. And that is that the average quality of research doesn't change a ton as labs increase. These are the sort of leftmost bars. It's interesting that maybe some indication that the interdisciplinarity of work goes down. So maybe in the larger labs, you're doing a little bit more narrow work, but in general, there aren't large declines in the quality of research, of the average quality of research. If you look at the best performance in red for each principal investigator, that actually tends to go up. That's probably not surprising. The more money you get, the more stuff you do, the higher the quality of the best thing that you do. So, you know, you're drawing more balls from the urn, you're likelier to get a better ball from the urn if you get to pull more balls from the urn. And then in some cases, we think we can generate something like a total for like citation counts or use of new concepts. And we see that, you know, because the average quality isn't going down and the total quantity is going up, sort of the product of the two goes up. The total amount of citations received, the total amount of new concepts used goes up as labs grow. So it looks like for most of the region, labs remain productive as you give them more research, and it doesn't look like the quality of their research is going down. Let's see. There we go. We can look at how long it takes, and we see a fairly linear progression in terms of output over time. So, you know, it looks like for a number of years after you get your money, you continue to remain productive. And then the question, as I say, is sort of how does all of this happen? And so the cool thing with Umetrics here is we can identify all the people who are employed on these projects. I'm going to focus here on you know, job titles, but we also have genders, race, age, ethnicity that we've imputed and so forth. And what you can see, we're focusing just on the job titles, what you can see is that as labs get larger, they tend to become much more staff intensive and much more faculty intensive. I mean, there's not much data out here, which is why this is these things are starting to get noisy. But what that suggests is that the way these labs are maintaining their productivity is that they're professionalizing their workforces, right? Rather than using graduate students and postdocs and trainees, they're focusing on more professionalized staff to produce research. So let me stop at this point. Our goal is to you know, build data that can help us really transform our understanding, not just of the research enterprise, but of the knowledge economy as a whole. The key, we think, is to focus on people and how people produce, transmit, and use knowledge. And our goal here really has been to produce data, not necessarily as the end product. I mean, we do think it's an end product and it's obviously an input into our research, but we think of this is Julia Lane's analogy, as a coral reef. You know, the way a coral reef gets to be a coral reef is all these different things start growing on top of each other, and to build data that other people can expand and extend, so that we can, you know, we can all learn a whole lot more about the production and value of research. So thanks. Let me stop and see if there are questions.
Thank you, Bruce. Nice talk. Lots of applause. There are questions in the chat, but if there are people that want to ask questions, I can read them to you. So the first one is, so 10 million could produce 30 papers in the hands of one group, or 30,000 in the hands of 100? I think there was some confusion about.
Okay, let's see here. So this is, I mean, we can go back to our figure here. Maybe I need to start sharing my screen again. That requires more Zoom mastery than I probably have. Okay, it's back, right?
Yeah. Yes.
Now I need to be able to scroll through here. So, so what we're seeing here is, I mean, so 10 million, I think we want to be a little bit careful with. Things are sort of trailing off here. But maybe if we can come here and we can say, look, if we fund one lab with $2.5 million, and we tend to believe, let me move down here. We tend to believe these fixed effects estimates more. So if we give one lab $2.5 million, we're going to get, you know, seven publications, say. If we split that up into 5 different labs, we're going to wind up getting maybe 2.5 publications out of per lab out of those labs. So if we do this, we're going to get somewhat more research from producing, from giving this money to 5 smaller labs rather than to one large lab. Part of that is that the intercept is positive. So it looks like simply getting NIH money is a good thing. That's part of why I say broadening and just increasing participation in this is in the STEM enterprise is valuable, but that's how you want to reduce this. I don't know how seriously to take these estimates out here. It does look like a $10 million lab is a bad bet for most purposes here.
So a technical question. So here, why is not so basically the difference between the OLS and fixed effect is like basically there's these huge outliers that are pushing the random effects up. Is that how to read this?
I think the way to think about the difference between the OLS and the fixed effects is this is our attempt to say that there's some folks who there's some folks who came out of the gate and clearly had brilliant ideas. I mean, we probably all knew some of these people. Maybe some of you guys are them. That clearly had brilliant ideas from the moment they started, and and the reality is that those folks tend to get more money than everyone else does. And so if we can say, let's look at that, rather than saying, let's look at how much money a particular person gets or their lab gets, let's look at the changes in the amount of funding that they get. There we're accounting for those fixed differences in the level of innovativeness across folks.
And this is data from NIH, right? So it's not Umetrics. It's just publicly available, if I understand.
These data, this portion of this project is this portion of the project is NIH data connected to publication data. That's right. This portion of the project is Umetrics data. Yeah. So the Umetrics is sort of like how does this touch people? This portion of the project is NIH data. This portion of the project are data that we've produced, natural language processing things and so forth.
Cool. Okay, Alex says thank you he clarified the question that I asked. So there is another question, and again, if you want to raise your hand and ask yourself, from Dominica, are there any systematic differences in careers of young academic staff from big, well-funded labs and smaller labs?
Yeah, it's a great question. We've not cut the data like that. We do have a couple of papers that we're working on now. And these kind of get to Stash's sort of scientific mortality curves, scientific survival curves, where we've been trying to show that that innovation tends to decline, that the quality of research tends to decline over the career, and that's hard to estimate because people tend to drop out of producing research, and it's the people who were sort of most promising at the beginning of their careers who last as long. Again, I'm an economist, so we talk all about causality and selection, and I can't help it. It's sort of like a congenital problem that I have, but there you go. Nick, it looks like you've got a question.
Yeah, I'm just going to throw another complexity into this already complex story. Do you have any insight onto dynamics maybe within a department where maybe one lab in a department has a lot of money and other labs have less? Does that create some sort of competition factor where lower funded labs then produce more or different type of work compared to a department where maybe the money is more evenly spread?
But that's a brilliant question. No, you get the data and do that. We'd love it. No, we've not looked at sort of those departments are a bad construct for us. We don't, just the way our data come, they don't come natively with departments, but one could absolutely say, here are folks who are working in a similar topical area and they're at the same institution. We'd love to go get our data. We'll give you code. Robert, it looks like you've got a question.
Yeah, it's sort of a natural follow-on to the last. So you're sort of looking at like concentration at the lab level and in funding. And I'm curious about, because we think these local sort of geographic spillovers are really important for science and innovation in general. I wonder if you've looked at whether increasing concentration within institutions, increasing the number of researchers within an institution, and then distributing that funding. There's sort of dynamics between like the institution level and that. I don't know if you've looked at that, I guess.
Yeah, we haven't. I mean, I think this is one of these things where, and maybe I've started to take on a little bit of this role as I've gotten, they took away my programming license a long time ago. So, sort of now my role is sort of to generate money and then hand it to people who are actually smart enough to do something useful with it. And that would be again, I think that I don't know exactly what the research design would be there, but I think we haven't done it. Would be a great thing to sort of look at that kind of rainmaker gatekeeper type effects. That'd be phenomenal. Yeah, Aaron, it looks like you've got a question.
Yeah, thank you so much for this talk. I really enjoyed it. And in fact, this question sort of comes out of both talks today, which is a question about interdisciplinarity in a sense, and effectiveness. So it seems to me that in some cases I may be trained in one discipline, right, and someone else is trained in another discipline, but in fact our methods are identical, right? So we'll be labeled interdisciplinary, right? But in fact, like what we do on a day-to-day basis, and even the communities of practice that we occupy, right, are going to be very similar, right? And so there's a weirdness about whether to call that interdisciplinary, transdisciplinary, or maybe disciplinary is the wrong way to even describe this. And so I'm just curious in the kinds of analyses that you're running, because I think following the money, I'm a historian, so I think following the money, I do that. That's one of the things I do, right? For better or worse, sometimes for worse. Do you have any thoughts about how to try to parse that problem, right? Like, are there ways that we can try to get at the communities of practice through the sort of methods that you were just talking about today?
Yeah, I mean,
thank you again.
Yeah, no, it's great. I love following the money. Brilliant. I love following the money. That's sort of, that's sort of one of the things I learned from Julia Lane was, I was trying to follow the citation. She's like, dude, just follow the money. That's where you find the people. But so I think it's a great trick. I think, Sasha and I actually have a project with Kevin Niffen and Drew Kevin at Cornell and Drew at Ohio State. It's looking at interdisciplinarity. We think it's incredibly important, and we don't always see that the personal returns to interdisciplinarity, or if you listen to public discourse, that the sense is that all the world's problems are going to be solved by interdisciplinary research. That may or may not be true. I'm not smart enough to know the answer to that question, but at least there's some smart people who think that that's the right way to go. But the returns do not appear to be there for it. And so I think, part of what I think of this project is doing is, that sort of hurts my brain as an economist, because I think, demand should be high, return should be high. How are we getting high demand and low return? That's not the way this is supposed to be working, folks. So that's kind of how I'm coming at the problem. But the measurement type questions that you're talking about are great. And I don't, I kind of think, maybe that's a little bit more a Kevin or a Drew question, but Stasha looks like she has a question she wants to ask. So maybe she wants to try to answer that before I take the easy questions. I try to turn the hard stuff over to, to smarter people than me, and just focus on this stuff where I'm like, hey, how do we think about supply and demand and so forth. But no, I think it's a great point. And I don't know, what we could talk about is the roles that people play on projects from Umetrics, but I don't know that we could say, this is the skill set that you have. We have, I guess on the other side, it's not necessarily on interdisciplinarity. We have tried to understand the skills and knowledge. This is work with Gabby Zhang and Joe Stout. We have tried to understand the skills and the knowledge that individual researchers have and how those are valued by industry. That's work that we're doing right now. but I don't know how to answer this question in the context that you're asking. Sasha, do you want to try to
So,
be more
well,
informative?
maybe so Aaron, thanks for the question. I don't have an answer, but it's something that really bothered me for a while. So in terms of like thinking about interdisciplinarity and what it really means, and like one thing, and we didn't get that far because it's very different to measure and capture. But one idea that I had, which I explored also with Filippo and John, was this ecology, right? So if you have teams, so what we were looking at was the team composition and the idea of the whole ecology of teams. So if all teams in a field have a biologist, computer scientist, and philosopher, I'm making this up, right? Are they really interdisciplinary, or you really need three? And if they all have the same three, it may not be interdisciplinary anymore, right? Because you need three, they always come together, they bring whatever they need, they may share methods, they may share data. So I don't have an answer because it's really complex, but it's something that like we've been marching through, and it's, again, I think it's more complex when you think about that when you bring teams and not individuals, like, and what if it's always the same, then, and if it's like if you're trained like that, and when does that become the norm and it's not interdisciplinary anymore, like you just have these skill sets and you move on. So yeah, I don't know if that's helpful. It just, but I think it's something that I'm really grateful for. Like, so, okay, I'm a recovering, so thanks Bruce for making me a recovering drunkard for the beginning of your story. So thanks to Bruce, I actually did move from just looking at papers to looking at Umetrics data and other sources of data. So I'm grateful for that. And I'm really hoping that we can that actually we can see some other things than just gazing into what we get by publications. So like that is one thing that I think, I believe that we need to look at the larger pictures, like combining these sources and trying to like patch these things together. But my question to Bruce is about risk. So you were talking more about the amount of money and the novelty, the measures of like funding. And I know that occasionally there are these notions that the agencies are more conservative at all levels. Like they are conservative for small and big equally, right? It's just the types of resources they need. So like, how does the risk play a factor, and should they have different strategies to maybe diversify the risk?
Yeah, no, this is a great, I mean, it's a fabulous question, and it's actually part of the program project that we wrote that you were a very different part of, that we're trying to answer with folks like Jay Bhattacharya and Mikko Packalen and so forth. I mean, I think, the question is sort of both at the, both the way I think about it, both at the individual project level, how much risk do we want to be taking on, but also sort of at the portfolio level, because I could, the way I think about it is, and so again, here's an economist speaking, but like I could buy a portfolio only of utility stocks, and each individual utility stock is fairly low risk. But if all I own are electric companies or gas companies, that's actually a phenomenally risky portfolio. So, yeah, if I'm going to buy one stock, maybe make it a utility and don't make it Tesla, because who the heck knows what's going to happen to Tesla tomorrow. But if I'm building a portfolio, you need to have a little Tesla and a little Amazon in there just in case they turn out to be right. And I think one of the questions that we have is whether by trying to sort of reduce risk, some of these funders have actually increased risk by taking on a portfolio that's all low risk and is therefore kind of actually fairly high risk, because you need someone to try out the crazy stuff, and occasionally most of those things fail, but occasionally you wind up with Tesla, and that's not a bad thing for society. So yeah, that's part of the project that we'll hope we get funded if it's not too risky.
Hope so too. That would be awesome to see. Thanks, Bruce.
Stephen, you want to ask a question?
Yeah. So one question I wanted to ask, just because it was something that came up in some earlier discussions this week. You met with the census data seems potentially incredibly valuable, although I imagine a little bit tricky to work with. So gender and race, these are things that people have kind of been able to tackle, but there's also this question of class background, so sort of economic background. And I'm wondering if the census data there's anything in census data that could be used to learn something about kind of that aspect of trainees and how that affects their careers.
No, for sure. I mean, that would be a great, I mean, we haven't done it. We would love to do some of that. I think those are ideas that we've batted around. I think we haven't sort of pulled together that project. As you say, the data are tricky to use. They'll even tell you themselves that the data are tricky to use, but they're freely available. So readily available. So and they're not free. We don't charge. Census charges its cost for providing them, but I encourage people to do that. No, I mean, we've done a ton of stuff with imputations. I should be clear, when we use things like gender, we take up, we're very, it's a binary, static view of gender. So I mean, there are huge limitations even in what we've done, but we haven't done that, and that is something that we've been interested in and been thinking about trying to do.
Okay, so that looks like a great invitation to continue exploring the data. Thank you, Bruce, for your awesome presentation. And please stick around. In an hour, we'll have the panel. And Jen has graciously agree to have a kind of a 7-minute break before her talk. So her talk will start at 10:55. Okay, so see you later. Thank you, Bruce.